All right, so this is going to be your pedigree lecture. And if you check out on Google Classroom under genetics unit resources should be your genetics note packet. So if you open up the notes document and scroll down, all of this should be completed. And when you get to pedigrees, that's where we're starting today. So make sure you have your notes open and you're following along. And then you'll also want your genetics practice set packet as well. So please make sure you have both your notes document and your practice set with you. Okay, so pedigrees are really just a family tree that shows relationships and tracks a particular genetic trait or disease, oftentimes in the history of the family, or even looking forward and trying to analyze the potential, the possibility of an individual passing on that trait or disease to their children. So in humans, pedigree analysis is important for studying inherited diseases. Again, a couple things we might look at is looking at the past, so the way that this disease has been inherited in the past in this family, and then also the risk of disease in future offspring. When we're looking at a pedigree, the males are represented by squares. So you can see here, these are squares, and females will always be circles. If an individual is affected by this disease or trait, then we would shade them in. So you can see up at the top here is an unaffected male. And then we have a shaded in square, which is representing an affected male. The circle would be an unaffected female, and shaded in would be a female that has that disease or trait. We represent a mating pair by connecting them with a straight line. So you can see here we have a male and a female. And then if they have babies, you can see in the bottom right picture here that the babies come from that line. So here we have a line coming down and they've had two babies. So we have a dad and a mom. They do not have this trait that we're looking at, but both of their offspring do. So they have a little boy and a little girl, and both of them have this trait. Okay, so here's just one example. This is not in your notes, and we're looking at factor 5. So factor 5 deficiency leads to a blood disease, and factor 5 is what we call normal or healthy. So on this pedigree, there's a couple things I want to notice. Number one, here's a shaded individual that has the deficiency, and here's another that has the deficiency. I'm going to right off the bat feel pretty confident that this is going to be a recessive trait because it skips the generation. So because none of these offspring have the trait, but they have a baby with it, tells me that it must be masked by a dominant allele. So this trait must be recessive. So you can see now I've kind of gone in and plugged in their genotypes, and the only ones I know for certain right off the bat are the individuals with this trait. And again, because I said it's recessive, we know that the shaded in individuals must be little f, and little f, f. Okay, so if you'll grab your pink packet, the last practice set is on pedigrees. And you're going to go ahead, follow along, and you'll write in the genotypes of the individuals. So the first pedigree is pedigree 15. And the question is to first decide, is this trait dominant or recessive? So again, because I can see that this trait is skipping a generation, there's none of the offspring here have that trait, but then again, it pops up. So I feel pretty confident to know that that's going to be a recessive trait. So what we know is that the shaded in individuals must be homozygous recessive. So we can fill in their genotypes. So on your packet, go ahead and write in, you're going to write in all the genotypes of all these individuals. So again, the shaded individuals will be little d, little d. Okay, now let's see if we can figure out their three children. So we know that they don't have this trait, so they have to have a big D. And the only thing that they can get from dad is a little d. So we know that all three children have to be big D, little d. Now, if we hop over to this spouse, so this female came and came into the family and they had two babies. We know that she doesn't have it, so she has to have a big D, but they had a baby with little d, little d. So this individual, she must have gotten a little d from each parent. So that means we know that this mom here is heterozygous. Actually, this is a good reminder. So if you notice how this pedigree has been labeled, so we label the generations with Roman numerals. So here's generation 1, generation 2, and generation 3. And then in each generation, we number each individual with a number from left to right. So here's person 1, person 2, person 1, 2, 3, 4, and so on. Let's look at these two individuals. So mom up here doesn't have the trait, so she has to be big D. But she could be big D, or big D, little d. We don't know unless she has more babies. Same goes with the individual down here. This individual we know has a big D, but it's a possibility that she got two big Ds or a big D from one parent and a little d from the other. So if you look here, this is how we'll represent individuals with unknown. So sometimes the dominant individuals are tough. So we don't know if they're homozygous dominant or heterozygous. So make sure you just write both. And first one is completed. Okay, so let's move on to question 16. So is this dominant or recessive? Again, it skips a generation on this side, which means that it most likely has to be recessive. So we'll go ahead and first plop a genotype for every shaded in individual that has the recessive genotype. We know then that all these shaded in individuals will be little d, little d. Okay, let's move over to these children. So these 4 siblings don't have the trait, so we know that they have a big D. However, if you notice, the only thing dad can give is a little d. So all 4 of these children have to have a big D and a little d that they got from dad. Okay, and let's look at the remaining children here. So these 3 siblings we haven't looked at yet. They don't have this trait, so we know that they're big D. And again, the only thing mom can give them is little d. So now we feel certain that these 3 children must be heterozygous. If we go up to the top here to these parents, this mom could be big D, or she could be big D, little d. So we actually don't know. Again, she'd have to have more babies in order to know for sure. So she'll be big D, or big D, little d. Over here, this dad, we do know him. So we know that he doesn't have it. He'll have to have a big D. And then, but they have 2 children that are little d, little d. And these children had to have gotten a little d from each parent. So now we know that he is heterozygous. And then the last 2 are at the very bottom here. These individuals don't have this trait, so they have a big D. And actually, we don't know. They could both have gotten a big D from each parent or a big D from one and a little d from another. So they're also unknown. Okay. Question 17. Now, if you notice here, for the first time, we don't have the trait skipping a generation. So you can see it's present here in generation 1, and then it's present here, and then it's present in the 3rd. And same goes with this baby. So they had a son who passed it on to their children. Notice it didn't get passed over here, but that doesn't mean anything yet, right? So because it's showing up in every generation, I'm going to guess first that it's dominant. So remember, the dominant then individuals could be big, big or big, little. We don't know yet. What we do know, though, is the individuals without this trait, and they must be homozygous recessive. So now kind of switch gears in your brain and imagine now the individuals that don't have this trait have to be little d, little d. So go ahead and write in for every individual little d, little d. Okay, if we go up to the top here and look at dad in the first generation. So we know that he has this dominant trait. And we also know that he had this offspring that has a little d from each parent. So we know that dad must be heterozygous. If we move off to these siblings, they have this dominant trait. So we know that they each have a big D that they had to have gotten from dad. And the only thing mom can give is a little d. So these two siblings must be heterozygous. If we go over here to his spouse, she has the dominant trait, but if you look here, she had to have given a little d from this to this daughter. So we know that mom is also heterozygous. If we go down here to the middle, we have two children here. So they have the dominant trait they must have gotten from mom. And the only thing from dad here is a little d. So now we know that these two individuals must be heterozygous. And we have two more left. So these individuals, they have to have the dominant allele, but we don't know. They could have gotten a big D from each parent, or they could have gotten a big D from one and a little d from the other. So those are the only unknowns on this pedigree. Okay. And the last question here is an example of a sex-linked trait on a pedigree. So if you read, it says the pedigree below tracks Duchenne's muscular dystrophy through several generations. Muscular dystrophy is an X-linked recessive trait. So it tells us right off the bat that it's recessive. Because it's X-linked, now we know that we're going to be tracking our sex chromosomes. So if you want to pause the video and go through right now on your pedigree and draw in every single sex chromosome. So for every male, given XY, and every female, given XX. And because it's an X-linked trait, we are only going to be attaching the alleles to the X chromosomes. So what we know about the individuals that have this trait are on their X, they have to have the recessive D. So now I'm going to just go ahead and plug in with a red marker, you can see a little d. So attached only to the X's. Notice the males do not have a D attached to their Y chromosome. So those are all the individuals that have this sex-linked recessive trait. Now let's go over and try to identify some of the individuals that don't have it. So these three males are going to be XY. And because they don't have it, their only one allele is going to be a dominant D. So X, dominant D, Y. If we look at this mom, so she's going to be XX. If you look here, this son had to have gotten his Y from dad. So the only place he could have gotten his little d is from mom. So now we know that mom is heterozygous. So we know she's big D because she doesn't have muscular dystrophy, but she also has to have the little d to pass it on to her son here. If we look at this individual, She is going to be unknown. So she could have gotten, she had to have gotten a big D from dad, but we don't know what she got from mom. So she could have gotten mom's big D or mom's little d. And I think that's everyone. Okay, so if you need to go back and rewatch any of these pedigrees, go ahead. And remember, I always suggest you doing your pedigree work with pencil because oftentimes you'll have to go back and erase some of your work and kind of start over.